Welcome to the Dr. Carolyn Coker-Ross Show, awakening your full potential and expanding your understanding of how to live fully and joyfully by making conscious choices that promote and maintain vitality in all areas of your life. Now here's your host, Dr. Carolyn Coker-Ross. Please be sure to listen to this episode in an environment that is safe. Do not listen to this recording while driving a car or operating any kind of machinery.
Welcome to the Dr. Carolyn Coker-Ross Show. Today my guest is Dr. Emeran Mayer, who's a gastroenterologist, neuroscientist, and professor in the departments of medicine, physiology, and psychiatry at the David Geffen School of Medicine at UCLA. He is the executive director of the G. Oppenheimer Center for Neurobiology for Stress and Resilience at UCLA and co-director of the CURE, Digestive Diseases Research Center. He is one of the pioneers and leading researchers in the role of the mind-brain-body interaction in health and chronic disease. And he has a best-selling book called The Mind-Gut Connection, which was published in 2016 and has been translated into over 12 languages. Welcome to the show, Dr. Mayer.
It's great to be in the show. Thanks for inviting me.
Yeah, well, I have a few questions for you. This is a fascinating topic, talking about the gut-brain connection and gut microbiome and how that impacts all of our health, areas of our health. So there have always been sayings in popular culture that kind of hinted at this gut-brain connection, and also certain medical conditions in which the gut influenced the brain, such as irritable bowel syndrome and higher risk for depression. So why has it taken medicine and science so long to look into this?
Well, I've worked my entire career and in this area, brain-gut connection. The microbiome came on later, 10 years ago, when the science in that area exploded. I personally believe so there's been zero interest, I would say, in medicine in this brain-gut connection until recently. The only way I can explain this is this famous Cartesian Split that decided hundreds of years ago that the church deals with the mind and that science deals with the rest of the body. And that is obviously, it's kind of interesting why this has been so prevailing. The model that I see and that I've always seen, so it's more than ever, is that the brain is really, it's not an organ to generate psychological problems and feelings. It's a supercomputer that runs our whole organism in a perfect way, tries to coordinate everything inside the body and outside the body. The reason that the gut is so closely connected in anecdotes and in language, lay language, is not by coincidence, because if you look at evolution, the first organisms, first animals floating in the ocean were these tiny marine animals called the Hydra, which were essentially floating digestive tubes with a nerve net around them that regulated when they opened one end of this floating tube, food came in, and then they had a peristaltic mechanism and it left on the other end.
That's similar to our digestive tract, is what you're saying.
It's almost identical. It stayed for millions of years, this design principle. And only later did our main brain develop. And it used the original, what we call the enteric nervous system, really as the blueprint for building our complex central nervous system.
When you talk about the enteric nervous system, you're talking about the nervous system in the gut. Because I don't think many people see the gut as part of the nervous system. Like lay people don't necessarily see it that way.
Yeah, they don't see it that way. Obviously we can't see that and we can't visualize it because it's hidden between, even if you could look into if you do an endoscopy, you wouldn't see it because it's sandwiched these nerve nets, just like in the Hydra a few million years ago. They're sandwiched in between the layers, the muscle layers of the gut. There's two nerve nets. They're interconnected. One deals more with secretion, fluid secretion, the other one with the peristaltic reflex.
Yeah. I just want to get into something that people will kind of understand why this is important. So when you talk about this nervous system in the gut. Some people refer to it as the second brain, actually. And the brain and that nervous system in our gut actually communicate back and forth, right? What are some of the ways in which a layperson could understand this important connection?
Well, if you just talk about the big brain and the gut brain can pretty much run all the essential functions for digestion by itself. It's an autonomous system, very clever, very complicated. It can move backwards, forwards when we vomit, So normally it doesn't need the input of our big brain. However, if something happens when you get upset, stressed, depressed, anxious, the brain then sends signals down and changes the basic function of the gut's nervous system.
For example, when people talk about having butterflies in their stomach, that's one of the ways in which anxiety may influence the workings of the gut brain or the small brain.
Yeah, and this is a good example that whenever you have an emotion in your brain, there's always a mirror image of that emotion in your gut brain and in your gut, even though you don't notice it. Even if you don't.
Like anger, for example, how would that be mirrored in the gut?
Okay, there's people that feel the anger in their gut, and it's the brain sends down signals to cause really strong, vigorous contractions and spasms, typically in the upper part of the stomach. Whereas with anxiety, there's different signals going down. So this is not a general emotional response, but each emotion has its own pattern, how it changes the gut. And this is what I always tell patients. When you have any emotion, just always remember it's the same thing the same thing that you perceive is happening at your gut level. You may feel it if you're a sensitive person, but a lot of people don't even feel it.
Because they're not even aware that
they're not even aware of it.
Yeah, they're not even aware that it might be that way. They're not aware that emotions can affect the gut.
Yeah.
So when we talk about the gut, there's a lot of talk now, like you said, in the last 5-10 years about the microbiome and I know you work a lot with stress and resilience and all of that. So how does the gut microbiome affect, or the microbiota affect the brain and our behavior?
Yeah, so clearly there's bidirectional communications. We just talked about how the brain and the emotions can influence the brain of the gut. It doesn't stay with the gut. Anytime you have an emotion, it will change the transit time it takes for things to move through the gut and the blood flow and secretion, and that will change the microbes as well. In addition, these nerves, these stress-mediating nerves that come from our brain, can directly talk to certain microbes and change their gene expression and their behavior. And so the microbes listen into our emotions. They are aware what our emotions are.
Are you saying then that if say our brain is chronically disordered, say, for example, in the case of somebody who's seriously depressed for long periods of time, and that can then go into the gut and cause epigenetic changes, like turning on gene expression or turning it off? Is that what you mean?
Yeah, so we do know that certain microbes, quite a few actually, their gene expression pattern, and particularly their virulence genes, so how aggressive they are towards their host or how they interact with the host, are turned on by norepinephrine, by the main stress hormone that we secrete, increases our heart rate, but also talks to the microbes. If this is epigenetic, meaning permanently changing gene expression, that we don't know. I personally always think that a lot of epigenetic changes happen early in life. So emotional influences of the developing brain could potentially cause long-lasting changes in gene expression patterns.
So, for example, in the case of people who've had adverse childhood experiences, we know that can cause long-lasting changes in the neurocircuitry in the brain. Does that also then cause changes in the gut?
I would expect so. We can't prove that. I mean, we've done studies on the brain and on stress responsiveness, so that's pretty well established. My feeling is that there's a similar effect that these early adversity events exert on events in the gut, both the microbes and also it will influence the composition. The first 3 years of life are the time when microbial architecture, community structure is established. If during that time there's major influences from the brain, like during adversity, that would affect that as well. So it could affect the microbes on multiple levels: gene expression, epigenetics, and also their composition and their community structure.
Because we do know that, for example, in children or in adults who've experienced adverse childhood experiences, they're more likely to have a host of medical conditions. Their risk for addictions, for example, or ADD, ADHD, eating disorders, and so on, and obesity is increased. And let's just take obesity, for example, because there are some studies that are showing that the microbiome is different in people with obesity than in people without. So is that an example of how, like, early life stress may have changed the microbiome, and the microbiome may be part of why these conditions occur?
The microbiome certainly plays a role. I mean, these are clearly multifactorial influences. This starts in utero. People always say the first 1,000 days in life are the most crucial ones in terms of lifelong programming. So that happens, the kind of food that the mother eats during pregnancy, during breastfeeding, how the baby is born vaginally, so all these factors interact on shaping the infant's microbiome. Adversity, both of the mother, the pregnant mother, that's been shown, as well as on the newborn, certainly play a big role in this. And it does affect, several studies on that, it does affect the microbial composition and function. One particularly interesting study done in mice. So when the pregnant mother was mildly but chronically stressed with a sound several times a day, that affected the microbial composition of the newborn mice. So if you think about what goes on for many women, pregnant women, in terms of, you think about the refugees, or you think about a lot of people that are...
Or even working women who are under so much...
Even working women, female students, I see that, or postdocs that have to finish a grant, which is stressful even without being pregnant.
Yeah.
And they have to do it. I mean, it's...
In the mice, though, so you said that if the pregnant mice mother was stressed with the sound, then the baby's microbiome is different. What implications might that have in humans in terms of what might show up in those babies later in life?
There could be a host of... This could be a risk factor for a host of diseases. We talked about obesity, but also anxiety, many brain diseases, or what I would like now to call brain gut diseases, autism spectrum disorder. That's obviously even more complicated. You need the genetic predisposition, but it could well be that, that the stress of the mother plays a role in that as well, the stress of the pregnant mother.
That's really almost revolutionary, don't you think?
It is, and this is the exciting thing for me about this microbiome, the brain-gut microbiome science. It will change fundamental concepts, the way we think about health and disease, in a way that we have not really thought about before.
Even just calling it brain-gut diseases instead of behavioral or brain diseases is revolutionary in a way.
That is revolutionary. And the psychiatrists, I guess many of them are still skeptical because they never thought about anything below the neck. So now you include the microbes in it, which is like...
mind-blowing for them.
Yes.
But they're going to need to come on board because the research is really pretty compelling, wouldn't you say?
Yeah, particularly the, what we call the preclinical research, so studies done in mouse models. This is one problem about the field. We have phenomenally interesting data and results from these mouse models, but there's really a limited number so far of high quality human studies that has confirmed that all this, what you see in the mice, can be translated into human disease. That's the reason for that is these human studies are much more expensive. You have to study not 10 mice in one condition or the other, but you have to study 1,000 patients. So the budget goes into the multi-millions. People are very So they're not inbred, so they're not genetically identical. Every human is different.
Yeah, that makes it hard to come up with stuff. But
nevertheless, I think we're seeing strange things happening that we can't explain. The obesity epidemic is something that somewhat came out of the blue, and it continues to expand worldwide. The autism increase. So the things that are happening another thing is many of these diseases are now starting earlier in life, so before
adulthood.
Like, for example, so colon cancer is another one that has almost certainly something to do with the microbiome. So before the main incidence, the main occurrence was in the late 50s, 60s. Now it starts in the 40s. Yes. Same with obesity. Now we have an epidemic of childhood obesity. So things are going on, which I personally think there's a pretty good suspicion that the microbes and how we interact with it, with our nutrition and diet, and plays a big role in this.
So let's talk about what we eat and how it affects the microbiome. And can you loop in there, have there been changes in what we eat over the past 50 years that might be explaining the obesity epidemic beyond the whole just push away from the table and exercise more kind of phenomenon?
Yeah, I mean, there's obviously fundamental things that have happened. I mean, since World War II, the end of World War II, the development of industrial-style agriculture, which obviously plays a significant role with all the implications, both in terms of how animals are raised and fed and treated with antibiotics. The same thing with these monocultures and the pesticides and the fertilizers killing the normal soil bacteria and interfering with this communication that the soil bacteria have with the plants. So this is, for a lot of people, that may be the most dramatic thing that has happened with our nutrition. Then the increased portion sizes, the increased sugar and fat content, the reduction... Fast food, the reduction of fiber. It's really a threefold change that's happened. Increase in fat, increase in sugar, decrease in fiber, a fourth one, increase in portion sizes. I think with those four, you could pretty explain a lot of what we're seeing.
Yeah. Okay, so what should people be eating in order to rehabilitate their microbiome, if that's possible even?
This is an interesting point. You cannot recreate a microbiome. So the world champions in microbiome health and diversity are people that live a few remaining hunter-gatherer tribes on the Orinoco River in Africa. They by far have the greatest diversity, which we now take as an indicator of microbiome health. We can't get back to that at the moment. There's no way, no matter how healthy you eat, you will not reach that same diversity. But you can, within a certain bandwidth, go from a low level to a higher level of diversity. And the recommendations is actually, the way to get there is fairly simple. If you think about all the things we've done to our food, it's not been good for the microbes. Decreasing fiber deprives the microbes of their main natural. If you increase the plant-based component of your diet, not with one vegetable, but with a whole variety of different types of vegetables.
So the rainbow of vegetables, as the dietitians call it.
And the reason that's important that we know now, because each plant has different types of fiber, has different types of polyphenols and antioxidants. There's thousands of these molecules. And if you just eat one of those, it will not be sufficient. You will only feed one type of microbe. If
so
you want to,
you can't just go buy an apple a day will keep the doctor away.
That won't help, even though very interesting, a recent paper has shown they looked at how many microbes are on and in an apple. It's billions, which is really, and it's really interesting. So people always talk about you have to take probiotic supplements and things. Well, if you think about it, you ingest 1 billion highly diverse microbes when you eat an apple, or when you eat a piece of cheese. A lot of the food that we eat is covered with microbes, outside and inside. Beneficial microbes, not pathogens. So increasing the amount of plants in your diet, so fruits and vegetables is one thing.
can you do that while, like, say you are a big meat eater, you're not going to suddenly become a vegan, which is what Dr. Ornish has shown has really helped reduce the risk of, particularly of heart disease. But a lot of people are never going to be able to follow a vegan diet. Does it still help if you're just eating maybe less meat and increasing fruits and vegetables in your diet?
Yeah, so a couple of comments on this. Yeah, we do not expect, even though the trends are definitely in that direction, that vegans and vegetarians are definitely increasing in numbers, particularly amongst younger people. Yeah, decreasing the amount, if you go from red meat 3 times a day to once a week, that would be dramatic already. The really important thing is, where does this meat come from? Because if these animals are artificially, in some ways, with corn fed in a very unnatural way that they normally would not in nature consume, their meat and the fatty acids in their meat, the composition of omega-3 and omega-6, the ratio will be influenced negative. So if you eat grass-fed and grass-finished beef, that will have less negative effect on your gut health and your gut microbial health. And the healthiest meat is wild game. And
so lamb, wild poultry kind of things?
Yeah, so bison, the American buffalo. I mean, so these animals have, this has been studied, have a much more favorable ratio there to the fatty acids. Well,
I used to live in Texas, and my grandfather was a country doctor there. And often his patients would pay him with deer venison meat or venison stew. And so as a child, I ate a lot of venison, but I hardly know anyone now who eats or prepares venison.
It's really a problem that we have shifted the cheapest, the easiest accessible meat are hamburgers, fast food. And that's obviously the worst. I mean, it's like...
But if you could eat a hamburger, you could use a bison burger, right?
You could have a bison burger, and now people eat this Impossible burger or these plant-based burgers. Yeah. I don't know how good, I mean, they are plant-based 100%, but they're also, it's highly processed food. So I don't know if that's the way to go, if you really mainly concerned about your gut health.
Yeah. So just a word about sugar, because sugar has become the new dietary villain in popular culture. You know, we had don't eat fat first and don't eat carbohydrates, and now it's don't eat sugar. Is sugar just a part of the picture?
Yes, sugar is a part of the picture. I'm always amazed. If you look at the preclinical studies in mice, 90% have been done with high-fat diets. And you can show all the negative effects that we're seeing, systemic inflammation.
With a high-fat diet?
With high-fat diet. So this is the standard experimental model.
Are you talking about, what kind of fat are we talking about?
Yeah, so there are unnatural diets, like 70% lard.
Okay.
Humans would not eat that diet, but we do know, so the science is out there. Sugar has equally negative effects, but it's not just sugar. You know, I've listened to some of these podcasts in the media. So there are all kinds of dietary gurus out there that said, oh, yeah, fat is good for you. That has to be really put into perspective. The total amount of fat is definitely not something you want to aim for to maximize it. You also want to make sure where this fat is coming from. So plant fats, obviously, and oils better than animal fat. So this whole new thing is that, you know, we were all wrong about the eating less fatty food is not totally correct, you know.
Yeah.
It's
well, I mean, I think there are a lot of popular diets now, the paleo diet, the ketogenic diet, that are all about just eat tons of meat. And
there are 2 comments about that. So one is not good for you. It's a fast way of losing weight. Yes, totally agree. And if you want to normalize, you have metabolic syndrome, have a quick change in your parameters. In the long term, these are very unhealthy diets. They're bad for your microbes. They starve your microbes of their main nutrient source. And on top of all this, I mean, they're bad for the environment. As you know, there's a lot of discussion now that we cannot, with the continuously increasing world population, we're not going to be able to maintain the meat consumption that we have had in the past. So the paleo people and the keto people obviously seem to have no consideration for the impact. I mean, the reason that half of the Amazon is burning now is because they want to clear land for raising cattle that they sell to McDonald's.
We've gotten ourselves in a pretty big pickle in terms of our diets and the environment being kind of butting heads in that way. So we do have to wrap up now. I just wanted to ask you if you have any last minute words of wisdom about like little steps that people can start to take. We talked about increasing the amount of fruits and vegetables, maybe being more careful about where you get any of the fat you eat, not so much from animal sources, but more like olive oil and grapeseed oil and those kinds of sources. Are there any other things? What about probiotics or eating foods that are fermented? Does that have a beneficial effect?
The science is not that strong. Probiotics, generally use probiotics, Bifidobacterium and lactobacilli. They seem to have, in a few studies that are really well designed, they seem to have a small beneficial effect on a variety of things. We don't know exactly why that is. They don't increase the diversity of your normal gut microbiome, but there's this evidence.
What about foods that are considered probiotic?
I think naturally fermented foods, that's what I recommend to my patients. Make that a regular part of your diet, be it kefir, yogurt, kimchi, kombucha, whatever you prefer, but make it a regular part of your diet. If you just do this for a certain amount of time, it's a waste of your money and your time. Anything with diet, you don't want to go on a short-term diet. You want to go on a long-term path, a lifelong path so whatever you do to improve your gut health and gut microbial health, you want to do for the rest of your life. And you want to pay particular attention when women that are pregnant and what they feed their young children. I mean, but probiotics, there will be a whole new dimension. People are now working, scientists, on microbes that have specific benefits, like short-chain fatty acid production, or that
be more customizable. You would take a probiotic.
Customize.
You take a probiotic for a specific problem.
You would do a test first of your stool, and you would identify exactly what microbes you're missing, and we're at least 20 years away from that. Many hurdles to get to that point.
Yeah. Well, this has been a fascinating conversation. I have personally enjoyed talking with you because I think this is such an interesting topic and, like you said, so revolutionary. So I appreciate your taking the time to do this podcast with me, and hopefully maybe we can have you back again.
Absolutely. It was a pleasure to be on your show. Thank you very much.
You have been listening to the Dr. Carolyn Coker-Ross Show. Please visit CarolynRossMD.com. That's CarolynRossMD.com to access podcasts, show archives, and more about Dr. Ross and her services.